Well, hello everyone. This is KP, the Math G. We're ready to do another video, and like I said, these next few videos, I've got quite a few videos prepared for, especially for the AP AB exam. All those free responses. I got quite a few. Well, I say a few, but I did get a few probably for the next 6 or 8 videos maybe. So I hope that these benefit you. I know that studying them certainly did benefit me, and I appreciate the opportunity that has been afforded me to try to help you get better at this test taking, doing the test taking. If this is, if you're taking just a regular calculus class, I don't know if you take this AP exam, probably not, but at least this will probably benefit you as well. All right, well, let's dive right in. This came from the 2024. This is question 4. We did a video on this the last time, but we did the first 2 parts, and this is the third and final part to this question. And I figured I would split this up because sometimes it takes too long either to explain, or it's just a lot more work involved here. Now it says find the value of d, in other words, the second derivative, all right, at point 3, 2. We found that point on the last video. They already gave us that x was 3, and from the last video we found that y is 2. At this point, is there a local maximum, a local minimum, or neither at point P? Well, from the last video we did find a horizontal line at that point. Now that tells me that that's probably either a local maximum or a local minimum, since we had a horizontal line. It's probable that it is one of those two. Now, what happens if we're finding the second derivative? What's the significance of that? Yeah, I mean, when you think about it, you are looking for concavity here. The second derivative means that you're looking to see if this graph, if this horizontal point is down here like this, and I'm just going to dot the line, that would be concave up. Now remember, concave up, I just say concave up like that. If it is concave up, what do you know about the value of the second derivative? Yeah, the answer is going to be positive, isn't it? So that means that this, all right, that is going to be greater than 0. Greater than 0. All right, concave up. If it's concave down, I drew that very fast, I'm sorry. All right, if it's concave down, here's our slope being 0 here. All right, our slope here is equal to 0. Then this is concave down, and that simply means that this derivative, this second derivative, is less than 0. I have a feeling it's going to be one of these two here. As a matter of fact, I already know which one it is. Okay. Alright, so be that as it may. And let's see, I'm trying to look for an eraser here. My eraser. Where did it go off to? Well, alright, I don't have it available right now, but I do have this cloth here. Alright, so I can erase all this. Alright, please, thank you. I beg you to bear with me during this time. But that's the idea. That's what we're looking for. This is already what we have here on the left is already the first derivative. It is actually given to us in the problem itself. If you pull up that problem, 2004, question 4, free response, question 4, you will see this already here. So we already know this is the first derivative. Now we got to find the second derivative, which is going to involve, again, as we did before, implicit differentiation, a combination of that, and what rule here are we applying here? Yes, that's right, the product. Not the product rule, the quotient rule. Yeah, I said it incorrectly. You said it correctly. I guess you did anyway. All right, low d high minus high d low over low squared. Okay, now let's do this. All right, so let's see. Low bringing that up, I always say when you make one move, you don't differentiate right after you bring it up. So now this one is, you're taking the derivative of this. This is 3, and some people say y prime, okay, dy over dx, if you want to, okay. All right, minus 2. Now remember, the derivative of 2x is just 2. Alright, minus sign. Alright, so now the derivative of this is 8 times dy over dx minus 3. And then keep in mind that well, we're going to go ahead and do this part down here, low squared. Alright, we're going to square that. Okay. Keep in mind that when you take the derivative of y, you've got to tack on that dy over dx there. Or if your instructor's been telling you to put y prime, then put y prime. Okay? Either way, it's the same thing. Alright, so the low d high, making sure I did everything correctly, minus sign, high, okay, derivative of high, and then low d high, and I should probably just say minus high. Here's the high here, d low. Alright, I put it in the opposite direction. That's okay, that'll work. So 3y, yes, just copy that part. Okay, now low d high minus high, I put it in the opposite direction, that's okay, d low, okay, over low squared. Okay, there it is. Okay, now remember one thing too. We have the x comma y. We could go ahead and start substituting that in there, but now what do you notice about this dy? We don't even have to copy all this. What do you know about dy over dx? Now that would come from a previous problem, but at this point we said that the slope, this slope right here is equal to 0. So this part right here is just equal to 0. Alright, so that's pretty easy to figure out. Now all we got to do now is just plug in the numbers and then figure this out. Okay, so I may have to flip the board over, but let's see. 8 times 2 minus 3 times 3. Okay, that, I don't need that L there. All right, times, this is actually 0. 3 times 0 is 0. So 0 minus 2 minus sign, okay. Okay, this is 8 times 0, which is 0, minus 3, times 3, alright, times 2, minus 2 times 3, alright, right there. And then this is all over, if I can squeeze this in, so 8 times 2 minus 3 times 3 squared. Alright, that's squared. Okay, let's see what we get here. I'm going to have to just write the answer above here. So let's see, bear with me on this one. Let's get a different color so we can kind of distinguish these. Alright, 8 times 2 is 16. So 16 minus 9 here. So we have 16 minus 9 times, alright, 0 minus 2. I do have that minus 2, yeah, that's right. So this is negative 2 here. Alright. This part right here is negative 3. And then this is actually 6 minus 6, isn't it? So we know that that's 0. All of this is going to be 0 here. So let's see what this is down here. This is 16 minus 9, and we're squaring that. Okay. So 7 times negative 2, alright, which is 7 times negative 2 is negative 14 over 7 squared. Alright, this is 7 squared. 7 squared is 49. And whether we reduce this or not, we can. 7 goes into 14 2 times, so negative 2. 7 goes into 49 7 times, and that's exactly what we got here. So now we've got d2y over the second derivative is equal to negative 2 over 7. Now, again, that is less than 0. Alright, so now, having done all of that, what do we say about this? If this derivative is negative, okay, then that means that the concavity is down. So concave down, and that's because the derivative is negative, okay? Concave down. And so what does that mean? Now don't say minimum. It's concave down. That's going down this way. Alright? Concave down means you have a max. Alright, so I was going to try to get this down. Let me put it over here where you can see it more clearly. So we had this, my ink is slowly running out. Let me rewrite that. Excuse me just a little bit. Okay, let's see. Okay, is negative 2/7, which is less than 0. And this means that let's see, the curve at point P is concave down, which also means that the curve is a max. Alright, it is a max, local max, at P. Alright, so that's what that is. And I think the author says because the first derivative is equal to 0 and the second derivative is less than 0, then we have a local max, okay? Alright, because this is concave down. And it confused me at first. I got to thinking, I said, well, concave down, I got to thinking, there's a min. Well, no, it's not a min, it's a max, okay? No, this doesn't determine max or min. This determines, well, this does, but this determines concavity. So this is concave down, which means that you do have a max. Keep that in mind. If it's concave up, you have a min. If this were positive, okay, then you would have a min. Alright, and so because this slope here is 0 and the second derivative is less than 0, then we have, then it is concave down, which implies that we have a local max. A local max. Alright, that's all I need to show on this video. So, be that as it may, that's kind of what I wanted to show here. And you just got to be able to, well, I mean, this was kind of crowded here, but if you look at this again, you just have to be able to differentiate this. Okay, you got to realize that is the quotient method. Okay, and at the same time that is that when you differentiate y, you tack on that dy dx there. Okay, and understand from the last problem that the slope, that slope was 0. Okay, all right, so we did have this slope being 0, and that helped to understand this. Hopefully that does help you to understand this. All right, that's everything I need to discuss on this. I have other videos that I may even do another video pretty soon, but this takes a few minutes to process, so it may be a little later than sooner. But needless to say, this is what I'm here to do, is to help you. Please, once again, as always, if you have not subscribed, please do so. Subscribe. I want to encourage that. And if you want to hit that like, you can. If you like what you just saw here, please hit the like. If you didn't like what you saw here, just don't do anything at all. Okay, now if you want to hit unlike it, okay, that's fine. But comment and say why you didn't like it. Okay, that would be only fair. If you don't like it, then tell me why you didn't like it. But anyway, I hope you did, and I hope this helped you. Okay, that's my main goal, is to help you get better. I want to get better, and this will make you get better. I can show you how to do these things. Okay, signing off is KP the Math G. Have a great day.